Okay, let's get started. So, today will be the last lecture of the semester, and so on Friday, I think I'm gonna skip the class so that you guys can have some time to work on the final project. Okay, so no class on Friday. I will send an email reminder. And this will be the last one. So I'm gonna show you how you can actually use DuckDB and LeafMap to analyze the data. You're welcome to use this in your final project if you find it useful. And so you kind of combine some of the things that we have learned in class and really put into practice how you really analyze those big data sets stored in the cloud, and you can get some analysis done pretty quickly. So here I'm going to go into the notebook just to show you, and there are different sections. I'm going to skip the first two sections. So in here, I actually show you the workflow, how I get started. For example, download the data set and then convert it to Parquet and then doing analysis. So this is more like in the real world scenario, because most of data set right now you find online, they are not necessarily GeoParquet or Parquet format. They might be GeoDatabase, they might be swap file, they might be GeoJSON or GeoPackage. And those data format are good for doing some mapping and some spatial analysis, but they might not always be the best suitable format to do some of the analysis we're going to talk about here today. And so the example we're going to use is the National Wetlands Inventory. So you're welcome to click the link if you want to learn more about the data set. So this is the one that provides all the wetland extent polygons locations in the US. It's the most comprehensive one. So it started in the 1980s, actually 1970s, and started manually delineate all the wetlands, and then now like using aerial imagery and with some automation. But this is the most comprehensive one if you want to use it for doing mapping wetlands. So there's a wetland mapper. This is where actually you can find the map. So if you click the mapper, you should be able to go to the website to see the map at different locations. So this is the global scale. It's like consistent classification. So if you zoom in, you should be able to see all the. So you include lakes, wetlands, and all kind of different types of wetlands. So if you click on it, you can see, for example, inspect the data set. And it's vector polygon, so it's not raster. So this is a huge data set. And so here I'm showing you like where actually I download the data set. So I download it from here, and it provides the data in two formats, geodatabase and also set file by state. They don't provide a single database for the entire US in a single geodatabase. So you have to actually download them one by one. So you can see if you want, you can click any of the geodatabase and then you just download it to your computer. So in here, I'm using basically, but you need to create the environment first. Some of the conversion require, for example, Parquet, GDAL, and DiffMap. So if you want, you can install this one on your local computer. This may not work on Google Colab. I have not tested yet. But this one actually is how I downloaded all the databases. Okay, rather than go here to click one by one and then download by state. So what this one is doing is actually using the state because if you hover your mouse on the map, hover your mouse on the link, the geodatabase. So at the lower left corner, you should see the taskbar about the URL, how it's actually. So I can actually copy the link and then just showing you Control V. So this is actually the pattern of the file format, the URL. So all you need is just basically change this, for example, the state acronym, the two characters represent the state. So all the links will be the same. So essentially we want to download all the data. But what we want is to get a list of like 50 states and also DC, and then just replace, basically generate the link of all the 50 files. And this is what this one is doing, right? So if you get this state file, so this one is from you can get it from anywhere, but it's from my website. So in here, showing you. So this is basically a CSV that you can download, but we are reading the file. If you open it, so it should have the column indicating the state name, right? So basically this column. So what we want is to get the list of all the names and then just use that to generate the URL, right? Convert to list and then sort from this. So this one actually shows you the entire all the states. Maybe I can come back to here to show you. Let me comb out the last one so I don't download it yet. Run this one. So you basically get the URL. So all the 51 URL, 50 states plus DC. So URL, right? Make sense? So right now, basically we're getting all the URL, and with that, you can just call the leaf map function download files, and then just specify the output directory and whether you want to unzip or not. So what we're doing here is download all the files. It's gonna take a while. I'm not going to download it again, but I'm showing you how do I get data from the website. Download it automatically, and then with that, I actually convert it to Parquet format. So as I said, if you so this is like 51 files, and the total I think is 30 or 40 gigabyte. You will not be able to handle that on a computer. Even if you try to merge that, you need the memory. So most of the computers actually don't have that amount of memory. So what we're trying to do here is to convert all the files from geodatabase to Parquet format. So in here, what we're doing is looping through all the states and then specifying, for example, which state we're processing, and then all the file names. So this is the geodatabase. And then inside the geodatabase, there's a layer called like something wetlands, for example, DC wetlands. So there's a feature class inside the database represent the wetlands. So what we're doing here is to convert the geodatabase to vector. So this one you can convert to Parquet, you can convert to any GeoJSON or shapefile if you want to. So what we're doing here is passing the database and then output the Parquet, the current directory, and then specify we want the Parquet, and the layer name is like something wetlands. Okay. So what this one is doing is take all the database, extract the feature class representing wetlands, convert to Parquet. If you want other format, you can do that as well. So this function is GTB to vector using this map that I created. So that makes it easy for you to create basic convert data format. And that's it. So pretty much after you have this, and then this is where actually host the data. So I upload it to source cooperative so that you guys can use it. So if you click the link, it should take you to this website. And again, the documents here are pretty much similar. On the left side here, browse. If you want to see, actually there's more data layers. So within each geodatabase, there are multiple data layers. So I only show you how to extract the wetlands, but you can do others. So after you extract that, it's pretty much the same, right? So AK underscore wetlands Parquet. On the right here, you can see the file size, right? It's pretty big. So each state, depending on how many polygons in there, the more you have, the larger the file size, right? So you can go through that. So in total, we have 51. So each page has 10 files, and you have 50 total. So what we are trying to do here is to actually do some analysis on these 51 files rather than a single one. So it doesn't matter how many you have, DuckDB can handle all of them all at once. So once we have the data set, then we can start doing the analysis. So I'm going to show you step by step how we do that. So the first step, again, we connect to the database, install the spatial extension. And the first one is actually to look at just a single data set because I know the DC is pretty small. And keep in mind, this one is pretty slow. Don't change it to a state with like gigabyte. It's going to take you a while because this one is still downloading all the data to your local computer. But for other analysis, we're going to cover later. It doesn't download all the data. This one, because you see here, it shows you all the columns. So actually getting all the data. So it should take you a couple seconds for a smaller one, but if you're doing a large one, it's going to take a while. So here shows you, for example, the column, blah, blah. And again, if you have too many columns, it's going to be hidden, dot. So for you, if you want to see all the columns, previously I show you like you can convert to a data frame and then show the data frame columns, but you can also do it this way. Describe from the file, basically the URL. And this one can show you kind of a so-called the schema. So you can also see all the columns within the table, and also you the data type of each column. So this is also, if you want to use this, you can do it this way. Or of course, you can convert it one to a data frame and then use the columns. So this each packet file, each wetland polygon contain the attribute and also the wetland type, the acres, the size, and also the length, and also the area, the geometry basically represent the column. Make sense? So basically, with that, you can visualize that, right? So in here, we cover how to previously use a longboard to visualize the vector data. So you can also use leafmat.view vector, and then you can pass in any geodata frame. And also there's another function called read packet file. So you can directly read a packet file from the HTTP URL, and it can convert it to a geodata frame. But you need to make sure that you're passing the source coordinate system and also the destination, because we're trying to visualize that. So all the wetlands data is in 5070. So that one is the corners, elbows, equal area projection. So we're trying to convert to 4326 so that we can visualize that on the map. So this one shows you how to read the data directly and then do the conversion and visualize that. I think we have covered this one in the previous lecture. I'm going to go through quickly. And you see, it's a bit slow. Again, it's downloading all the data set. So this is because my longboard version is like 0.04 something, so it's messed up. But you can update it to the latest version. It should work. So 0.03. I think I specify somewhere at the beginning. Yeah, update to the latest one. It should work. I'm gonna just skip. So because we're not focusing on visualization, this portion, and also you can visualize, for example, in different color. We have covered this, and also create a laser. So next, let's go to the real analysis part. Okay, and this is where DuckDB really shines, and it's really powerful and really fast. So in here, look at this statement, right? Select count star as count from, and this is the path. So this is basically the AWS S3 bucket. So basically, if you're using the HTTP, you can only access one file. The S3 is like cloud platform, cloud storage, and all the files you can access all at once. So what we are doing here essentially, if you see this URL and then the /star.packet. So what it's doing is like, okay, ask DuckDB to read all the files. Star.packet means represent the wheel card. So basically anything under this one. But again, if you're doing individual one, it'll be like this. HTTP, blah, 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 something. So that one, you cannot read multiple files. So you need to actually know the original file path. So everything here is actually stored in the AWS S3 bucket. Basically, it's like kind of like Google Drive, but it's more like other cloud storage services. They allow you to store files and also retrieve the files. So what we're doing here, keep in mind, right? The file is 75 gigabyte. So all the files combined together is 75 gigabyte. And what we're trying to do here is to count the number of files in each file and then aggregate them all together. See how fast it is? 6.8 seconds. So roughly 7 seconds. So 7 seconds, we have processed 70 gigabyte. If you're trying to do that on a computer, good luck. It's going to take you hours to do that. And you might not even have enough memory to do that. But right now, you see, so fast. And how many, in total, how many wetlands, right? 3, and then 3.8 million? Oh no, 38 million. Okay, 065251. So 38 million polygons counted in just 7 seconds. And this is the power of using DuckDB. And we can do it even better. So I'm going to show you this one, right? Because we have 51 states, right? So we know like right now total is 38 million. But how about each state, right? So if I'm asking you, which state has the largest number of wetlands, right? And we can certainly do that. You can download the file, or you can open in ArcGIS, QGIS, and then you can just count how many each one, and then do the or you can look through all the files, but then just try to count them. But using the database, we can do it just one single line. So what we're doing here is, okay, select, let's read this one here. Select the file name, count, blah, blah, from the read packet. And so compared to the earlier one, right, we just from, and we just from, just this URL. But it's under the hood is using the read packet function. So the read packet function has the file name. You can pass in a file name equal to true. So what this one is doing is reading the file, get the file name, and then add the file name as a column into the output. Let me show you what we better understand what I'm talking about. So the reason why I'm doing this because the polygon, the wetland itself, doesn't have a column indicating which state is that polygon coming from. But there's a file name. The file name, if you see from here, right? So right now what we're doing here is like the file name is blah blah something. It doesn't show you in here. Let me show you like all the file names. Right? These are all the file names. So what we are doing here is asking, okay, DuckDB, read this file and then tell me how many wetlands in this file. And that's the column, the count. And then add another column called file name. And the file name, grab this one, change the column. So in that way, you know, right now, okay, this one from, for example, from MN, for example, from Minnesota. So how many wetlands? Blah, blah, how many wetlands? Of course, this doesn't look good because we want the short name. I'm showing how to do that. But this is essentially what this one is doing, right? So the only thing that's like more than what we have covered in the past is we explicitly use the read packet function, and then we add the file name in the column in the result, so that in the output we can select the file name and also the count, and then we group by the file name. So group by the file name basically means each file name you're going to have the count, and then we're going to order in descending order how many counts. And this is why, for example, the first one, Minnesota, is the first one, last one, the second, the third, right? So we can do a little bit better, right? Let me just write this one. So what this one is doing is converting, create a new column and extract just the state, extract just these two characters as a new column rather than a file name that's pretty long because we don't care about the file name. And see this? Is it nice? Clean? So now we're basically getting the state and also the number of wetlands. And what this one is doing is adding this one. Select substring, the file name, and then get this. This is kind of like Python, right? The start. Give me a string, give me the start index and the end index. So what this one is doing is counting from this file name from the end, right? In total, how many? And then so this is roughly like 18 characters. So you minus 18. So you start from here and then you get 2 characters. So start and the number of characters is the state. So we give you a new name as a state. And the count is the same as the one, how many wetlands in that one, right? So these are pretty much the same as the previous one, except right now we have these 2 columns. And this is exactly what we want, right? How many wetlands in each state, and return a table, something like this. So then right now I can see clearly, for example, what are the top 3 states that has the largest number of wetlands, right? So Minnesota, Texas, North Dakota, Montana, which this one? Wisconsin, South Dakota, Alaska. But this only shows you like the number of wetlands, right? So Minnesota has over 2 million. But if I ask you the other way, like which state has the largest total area of wetlands? What do you think? This is count, like how many? But it can be large, it can be small. But I'm asking like in total, if you aggregate all the area, which US state has the largest wetland area? Texas? Anyone else? Florida? Yeah, we'll find out later. But what I'm showing here, right now showing you how to count, but you can do a lot more. So with this, for example, right now I'm asking you to create a map, right? And I give you, and right now you know the state, you know the wetlands. Can you create a map to show, for example, the number of wetlands in each state, right? Give me some like Chronopolis map. So this is what this one is about. Okay, I'm gonna show you here. So what we're doing is that right now we have this one, right? So the count df. So this is a data frame. We can actually create a table. So right now we are storing this one in the database. So create the table from something you can actually pass in just a variable of the data frame. So this one actually is Python variable. And then we're going to show you, okay, right now we have this data table, 51 rows, right? So 48 or 50 state plus DC, and you have all the numbers. Then I'm going to show you how you can actually, so I'm going to grab, I have another Parquet file, so US state boundary from my website. And so this one is a vector data. I'm going to show you here. So right now we are reading this file. You should be familiar with this one right now. We have covered this in the past. So we're reading the Parquet file and show you the content. So this is the Parquet file. It's the vector with the column about the state and also vector. And the previous one here, right? So this one has the result, but it doesn't have the vector, doesn't have the geometry. So what we're trying to do here is to join a table, right? Kind of like in desktop.js, you have a spreadsheet with all the result. We are going to join to the swap file, and then so you can create a map. So what we're doing here is that right now I have these two files, and look at this line, right? Select something from the state. So the state is the one with the geometry. I'm going to join the wetlands table. The table has how many wetlands, the wetland column, the count. And then we're going to join based on the state ID and the wetlands dot states, right? The wetland, the state's ID is this column, right? First column. And the wetlands is the state column, right? So these two are the same. So right now we are joining these two columns. So take a look. Make sense? So right now we join this one to the geometry, and so this one is kind of duplicate. We can just ignore one of those, and this is what this one is about. Okay, select the name, basically select this column, and maybe the state column, and also the count, and also the geometry. So that right now you can see this is exactly what we want, right? So right now this is a pandas data frame. So with the name, the state, and also the count, right? So what we can do is actually convert this one to a geodata frame, right? So use diffmap.df to geodata frame, and then just passing, it's going to use the geometry column automatically. So now if I run this one, okay. Lastly, we can use the diffmap add data function to create a map automatically. We are passing a geodata frame, and then tell the map to use the count column, create a map, and then we use the quantize. So basically, separate into 5 categories. It's 4 or 5? 5. So and then we use the different color. So this one is the map property color, and then the legend. Okay, basically just one icon. So now if you zoom in, okay, and this you can clearly see it's better than the number, right? Better than the table, because you can see which state is the most wetlands. You can have a mouse. This one shows you, for example, the number of wetlands each category. So basically the range. So clearly, right, the dark blue color represent more wetlands, right? This one is less. Okay, Phoenix, right, because it's a desert, so it's don't have many wetlands. And what's this one? West Virginia, New Hampshire, New York. Okay, so most of those are concentrated, I mean, in the north central area, and also in Texas. So this is pretty kind of workflow, right? You get download some data, analyze it, get some result, and then you might need to do some join, spatial join, or join the table to the vector data, and then you can display the map. And then you can zoom in, you can zoom out, you can inspect that. You're welcome to change the color. So for example, if you don't like the green, I can change it to, for example, to blues. You can use any color, like you just type the name. If it doesn't work, it will tell you, right? So this one, similarly, like one line of code. And if you don't like, you can change to other color scheme. So if you have your mouse on here, it should tell you, for example, by default is quantile, how many classes, you can 4, 5. And so for the classes, you can use, for example, percentile, standard deviation, max p, for example, equal interval, for example, right? So see, so the map is going to look different. So this is kind of similar to in ArcGIS or QGIS. See here? Is it different now? The equal interval right now, basically the legend will be different. So you will clearly see right now you have more white color. Earlier is more like rank percentile, rank into from the largest to the lowest, and then you separate into 5 categories. But this one is using the value, the absolute number. So sometimes you might, if you have some very extreme, you might end up with all the all the states in one category and the other in the other category. So depends on how you want to do that. You can change the color scheme. And next, you can create some pie chart, for example, because we have that column at the data table, so we know exactly how many in total, how many wetlands in the US. And so basically each state divided by the total, you get the percentage. So in here, right, pretty nice. You have your mouse, you can see like Minnesota on the right here also shows you the legend, right? So Minnesota has the most, and then Texas, North Dakota, and you can also turn it off. If you click here, you can hide some of those that if you don't want to see it, you can hide them. So in that way, you can know that, for example, okay, if you're trying to study, let's say, wetlands in the corners without counting Hawaii and Alaska, you can hide them, right? So where's Hawaii? Is it here? Okay, the bottom, right? I can hide it. And Alaska, where's Alaska? AK, right? You can hide those two. So right now you're only looking at percentage for the contiguous US without Alaska and Hawaii. And similarly, you can create a bar chart. Okay. So those are pretty simple. Most of those are just one-line code, passing a data table. Tell me which one is X, which one is Y. And then also the title. Title is this one. Now you see, give you a nice table showing you order by the number of wetlands each state. This is how you can do that easily using DuckDB. So if you run all the process, it should take you a minute or two. Compared to using desktop.js, this is definitely hours. I used to do this manually, try to write a Python looping, okay? Do the looping and then open the file using GeoPandas, and it takes 10-20 minutes to open a several gigabyte file. And after that, you need to like count how many, and then you create an empty table, and then just read the file name, the state name, and then was populated, loops through that. This easily takes hours. But now you see, seconds, minutes, you get it done. I love it. So I don't have to spend so much time trying to do it manually. And nice thing is you can loop, you can aggregate all the files. Yes? Uh-huh. What do you mean? Uh-huh. Yeah, you can get all the information. So the Parquet file contains the whole table. But what we're doing, we only deal with the count. So it doesn't matter how many columns in there. That's why it's so fast. But the other example I want to show you here, this one we are actually accessing the column information. So as I mentioned earlier, if you go back to the data table here, right? So this one contains the shows you, for example, the information inside. So the columns, right? So it has a column square, a shape area. So that one is basically the meters, the size of each wetlands. So earlier we count how many, so it doesn't matter how many because you can count how many rows. But right now we are really counting the area. So this is the question I asked you earlier, right? What's the total wetland area in each state? So that will be using this code block in here. So let me show you. Where is it? Oh, here, only 2 more blocks. Look at this one. So we're gonna select sum by the swept area divided by 1 million. So basically converting from square meter to square kilometer. And that's it. So what we're trying to do here, see, like right now we are calculating the total area, total wetland area. Earlier we count how many, so it's like 38 million wetlands in the US. But right now we are counting the total area. Basically is reading that whole column. And this one is a bit slower because you will need to actually get the number and then aggregate them all together. The previous operation basically count how many rows. You don't care about the number. So this one you see is a little bit slower. So it takes about 3 minutes to run, but it's still better than you open using desktop GIS. This one is like take you hours, and then you might not even be able to calculate it because it's just so slow, because you need to grab all the 38 million numbers and then put them all together and then calculate the total area. So it's pretty slow, but you can calculate total, and similarly you can calculate the wetland area by state. So similarly, we can extract the stream like it's only one, similar to what we did earlier by count, but right now we are doing like sum of the swept area and then divided by 1 million, you get the square kilometer, and then also order by state. So look at this one right now, right? 1.4 million square kilometer. Very nice. And then you can also do it by state. So similar to what we did earlier, we calculate by count, but right now we are calculating by state. And again, this one takes a couple, is this 3 minutes? Oh, this is actually faster. So less than, so it's 1 minute, 8 seconds. Pretty good. And you can do something similar. So this one also shows you how you can calculate area by total. But you can do a lot more. You can select a certain type of wetlands. So if you're only focusing on a specific one, you can say blah blah from where wetland type equal to lake, whatever wetlands available in that database, and you can also do the calculation. So we can do a whole lot more analysis just simply writing this one code block. So it's not that complicated. So all you need to do is look at example, modify to your own data, or you can use ChatGPT to ask like how to do that, or Google GitHub Copilot when you type. So for example here, if I hit enter, did it auto-complete? You see? Where wetland type equal to something. So you're focusing on just one type. You can do that as well. Look at this. So now, instead of using count, I get the area of each one. So the largest one, is it still Minnesota? I think I saw it's like last night when I talked is Alaska or something. Anyway. Okay. Oh, AK. So why is the Alaska not showing up here? It's weird. Aerial, oh, this one is yeah. Yeah, the top one should be Alaska. Something is 66. Oh, because there's no order alphabetically, order by group by state, count group. Oh, it's using count. It's not using. Sorry, this should be using the area. Because I'm using the count, so it's still using the previous how many rows. But by area, it should be Alaska. So that statement need to be updated, and you can also create a bar chart, for example, right? Similarly, so now clearly see, right? Alaska has the most wetlands. Makes sense. They have a lot of lakes over there. Okay, so that's all I want to show you. But again, you're welcome to explore. There are a lot more things you can do, and it's so fast. Processing massive data in seconds, minutes. Okay, so that's all for today. And again, no class on Friday. Work on the project, and we'll see you on Monday next week. Yes.